Hello guys, this is Ashish Rai. In the previous lecture we have talked about Newton's 3 laws of motion, and in previous lecture I have introduced some terms like first law define us about vector sum of forces is 0 and inertial frame of reference or systems, and second law give us the name or term called inertial masses, and third law give us that forces is in pairs. So firstly we will talk about vector sum of forces is 0. Consider an example in which a body is at rest. You always know from Newton's first law, if a body is at rest, always will remain at rest. Then we know that gravity is pulling it downward. If only gravity is available, then it will compress through the surface. So there is some force which will act opposite to each other. This one, which is called normal force. So the total force acting on this body is 0. Or we can say that if there is air pressure or other forces like F1, F2, F3, the vector sum of all the forces should be 0. So then we will talk about inertial reference frames. Firstly, we should know what is a reference frame. A reference frame, simply we said it a set of coordinates which will be assigned to a specific body or system, so we can know about their dynamics. Let me give you an example. Here is standing a person and here is a pole. For this person, this pole is 5 meters away from it. Like positive, we can say that if here is a positive x-axis going in this direction, or let it is 0, then for this person, the pole is nearly about positive 5 meters in x-axis. And for this person, if we talk about this person can say that the pole is behind him 2 meters. Or we can say that if a person is driving a car, for this one, everything surrounding him, he said he is in stationary position and everything around him going backwards if the person is going forward. For this one, the pole's position is always changing. So we can say that for all the respectives, all the coordinates for the pole are changing and will be different. So these coordinates for different person have their different reference frames. And the frame which follows Newton's law is called inertial reference frame. Generally we say that an inertial reference frame is that which travels with constant velocity with respect to any other frame. To properly define that, you can say that the person is sitting here or standing here on the earth, because we know that earth is revolving around its axis, so earth should have some acceleration, and you also know that earth is revolving around the sun and the whole solar system around the center of the galaxy. So properly defining the inertial frame we can say that an inertial reference frame which follows Newton's first law basically. So let me give you an example. We have two frames or two persons sitting here, like that one is here. He has his frame X, Y, and Z, and another person here, his frame is like X1, Y1, and Z1. 0 origin, and we should want to talk about the point P here. From his perspective, the point P has position vector r, and from this perspective, the position vector is r dash. And from vector subsection, you can say that this could be capital R, somewhat what we want to know, r minus r. So let us calculate the force on this point in his reference frame and in his reference frame. So force according to Newton's law, m mass of the body, d double differentiable of position vector, and force for this person, m double differential of position vector by respect to time. So subtracting these, let us calculate my f minus f dash, which is equal to m minus dt square, or you can say that this is r dt square. In Newton's law, we should calculate the force on this point. If both frames will be inertial, the force on this point would be seen in this. And so we have to calculate. Let us make it equal to 0. There is no difference in the force calculated by this person or this with respect to this person to that point. So we can also tell that m can not be 0, but if that can be 0, it means if it is 0, integrating it with respect to time, we get a constant which is, we can say that, relative velocity of these frames. So from here we can get that the inertial frame are those frames which travel with constant velocity with respect to each other. Constant relative velocity, you can say that. And so let me give you another example. You will get the reason behind it. We have a system, inertial system, and we also have some bunch of particles in it. Like here, 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 here. So in inertial reference frame, what we can say that if one of the particles is moving in the right direction with some velocity v, then all particles should move in that direction with the same velocity v. We can't find a single particle which have a zigzag motion. Okay, and for second law gives us the term inertial masses. What do you mean by inertial masses? Inertial masses, let us take an example of two bodies. Here is a body A and body B, or you can balls. It has mass m1 or it has mass m2. We apply same force on both balls. So force for this one is m1 a1, and force for this one is m2 a2. Equating these, m1 a1 is equal to m2 a2, and m1 divided by m2 is equal to A2 by A1. And the mass we should calculate by doing this experiment, M2 is equal to M1 A1 by A2. This mass is called inertial mass. And the mass you calculate by knowing the gravitation force between the two masses, like according to this formula. Here is the r distance between two masses. These if you calculate mass by knowing gravitational force between them, then this mass will be called gravitational mass, and this is what we call inertial mass. You should know about these two terms. And now third law. Third law simply say that force exists in pairs. It means you will easily know about, if you remember all the laws. I will give you an example. So Newton's third law tells us about forces exist in pairs. If you easily have remembered all these laws, you will get this example. It says that we will never find, let me give you like properly define this. We have an inertial reference frame, and in which we have some particles. We will never find a single particle who is accelerating, and all these particles are at rest, or some of particles are moving with a constant velocity. We will never find a single particle which is accelerating, but we will find us accelerating another particle. So we will say that if some force is acting on this particle, then there will be some forces acting on another particle in the universe. We will never find a single particle accelerating. So we can say that forces exist in pairs. So thank you.